Good morning all. Myself Mr. V.R. Sanap, lecturer in Mechanical Engineering Department of Kekiwak Polytechnic Nasik. Friend, today we are going to discuss about classification of CNC machine. So the classification of CNC machine tool can be done in four ways. The first one, it is based on control system characteristics. Under such category, it is further divided into point-to-point position system, straight line system, and contouring. It is also called as a continuous path system. The second is based on positioning coordinates, in that incremental system and absolute system. The third one based on feedback or type of control system, open loop system and closed loop system. According to the structure of control circuit, that is analog system and digital system. Friends, we will see one by one. The first, that is the base on control system characteristics. So in this method, that is point to point system, the cutting tool or the table moves from one point to another point. Machining is done only at a desired point. No machining is done when the spindle moves from one point to another point. This system is suitable for drilling operation, reaming operation, counter boring, tapping and spot welding. As shown in figure, the tool will drill a hole at a point 1, then it will have a idle movement up to the point 2. At point 2, it will again drill hole and move idle to the point 3, and again it will be move idle to the point 4. In this way, here the tool can move from point to point. So this is point to point system. Second is the straight line system. In this system, the cutting tool moves in a straight line during machining operation as shown in figure. This system is used in milling of slots or grooves. Straight line cuts parallel to the horizontal axis can be programmed. Angular cuts are not possible with such system because the tool motion along both the axes needs to be controlled simultaneously. The system which can perform straight line cuts can also perform point to point movement. Next, that is contouring system. In this system, the motion of the tool and workpiece are controlled along many axes simultaneously, and this facilitates machining of different types of curved surfaces, profiles, taper and angular cuts. The feed of the tool is very close control so as to move the tool simultaneous in required direction by synchronizing movement in both direction. The cutter path for the three system is shown in figure. So such contouring system can be used as a point to point system as shown in figure. Here the tool can move from A to B, B to C ideally. Then in diagram B, here straight line system, that is machining between A to B and B to C. And third is the contouring system. Here machining can be done between A to B point. Then second classification of CNC machine tools on the basis of positioning system. The first, that is the absolute system. So in absolute system, the coordinates of the point are shown in figure. So here the coordinates of the points, that is here along x-axis as well as along y-axis. So the fixed point is generally the southwest corner of the table for milling, and the workpiece center point on the other end of the chuck for the lathe machine. It has an advantage to write the program easily. It is also easy to check and edit a program. Consider this figure. The coordinates of the points, that is P1, P2, P3 and P4, in absolute system is taken as a coordinate for point P1 is 1 and 4, then the coordinate at point P2 2 and 1. So 2 is the value of x coordinate and 1 is the value of y coordinate. Then at a point 3, here the value of x coordinate is 7, whereas the value of y coordinate is 6. In point P4, here the value of x coordinate is 3, whereas the value of y coordinate is 2. So this is the absolute system. Then second, that is the incremental system. In incremental system, the coordinates of any points are calculated with reference to the previous position of the tool. So it becomes difficult to edit the program written in an incremental mode. Its special use in writing subroutine program. So consider this figure. So the coordinates of the points, that is P1, P2, P3 and P4 as shown in figure. Here the point P1 is there, then P2, P3 and P4. So all these points are in incremental system is taken as, where at point P1 the value of x coordinate is 1, whereas the value of y coordinate is 4. At point 2 the value of x coordinate is 1, because in previous position the tool is at a point 1, and when it move from 1 to 2, that time it travel only 1 mm distance. Here we have to consider the previous position of the tool in incremental system. That's why the value at point 2 of x axis is 1, where the value of y coordinate at point P2 is a -3, because initially the tool is at point P1, but when it move from P1 to point P2, it move in downward direction. That's why the negative sign is taken. At point P1, here the value of y coordinate is 4, but when it move from P1 to P1, P1 to P2, that time here the value is -3. Similarly, at point 3, when this tool move from this P2 to P3, that time the value of x coordinate is 5 at point P3, whereas the value of y coordinate is 5. Now when tool move from P3 to P4, means now here the tool is move in downward direction as well as its left hand side direction. That's why the value at P4, that is the value of x and y coordinate, is a negative. So here at point P4 the value of x coordinate is -4 and value of y coordinate is -4. So this is about the incremental system. Now the third classification of CNC machine tool, that is based on the feedback system. Again it is further classified as open loop and closed loop. So here we are going to discuss about open loop control system. So as the name suggests, open loop control system has no loop, or the loop is open. Since there is a no feedback device, it is a simple to design, less expensive and less accurate as compared to closed loop control system. So as shown in figure, it consists of input device which loads the program in the machine. The program is decoded in the machine under stable format and the required signal are sent to the MCU, that is machine control unit. The MCU sends a series of electrical pulses to the drive unit, that is to the stepper motor. This results in motion of the slides through the desired distance. So the stepper motor is used to drive the work table of the machine. The output shaft of stepper motor rotates through a fixed angle in response to an output pulse. Hence, the stepper motor converts the digital electrical signal into proportional movement of the table. However, there is no provision to ensure that the slide has actually moved through the desired distance only, and that it has actually acquired the desired portion as a result of this movement. The actual movement of the slide may vary with change in external condition, may be wear of drive components or backlash error in the lead screw. So this is about the open loop control system. Then second, closed loop control system as shown in figure. Here the input device is there, then comparator is there, then machine control unit, stepper motor, then table, workpiece, lead screw, then feedback device is there, and this is the feedback signal given from feedback device to the comparator. So the name indicates that the closed loop control system has a loop that is closed as shown in figure. A feedback device is used for the purpose. This makes the design of closed loop a little complicated and expensive, but a very high degree of accuracy is achieved in the movement of slide. This system is similar to open loop control system, but it consists of two additional devices in in the form of feedback transducer and comparator as shown in figure. The transducer feedbacks the actual slide displacement to the comparator. The comparator compares the actual achieved slide movement with the command signal. If there is any error, then it is feedback to the MCU. The MCU then sends the corrective commands to the drive unit, that is stepper motor, and the cycle repeats until there is no error signal from the comparator. So this is about the closed loop control system. Now next, that is according to the structure of control circuit, analog system and digital system. Control system may be divided into analog and digital system. In an analog control system, the quantities may be varied continuously. In digital system, they are varied as per the presence or absence of quantity. In digital system of machine tool, each cycle of information provides a voltage pulse where each pulse represents a basic length unit which determines the system resolution. Therefore, the digital system is of fine accuracy while the analog information can accept any value. The accuracy achieved in an analog system depends on the accuracy of various components used to construct the electronic circuit and on the precision of sensor which is used. Practically in a digital system, it is easier to obtain high accuracy. Then both analog and digital system are used in CNC machine tools. The input of the numerical control system is always digital as the dimensions that are from the drawing are given in numbers which are in digital form. The output of numerical control system is always analog as the slides of the machine tools are moving in a continuous and straight path. Therefore, each one of the system type contain analog and digital information in it. The type of control, digital or analog, is called by type of information appearing at the control loop. Whenever a control loop sequence of pulses is applied, the control is digital, and if the input is continuously variable, the control is analog. Thank you.